All right, welcome back, guys. We left off kind of talking about pseudoscience and some kind of how do we know stuff. So while in science and in life, it's sometimes fun to speculate why things are the way they are. But in science, any knowledge about the world is ultimately going to be based on evidence. We need to know what that is. It can be evidence from observations or experiments, and give scientists they gives them a chance to test ideas against reality and what you kind of see. All right. For instance, like when a crime is committed, sometimes investigators collect evidence like fingerprints, eyewitness statements, but in a court of law, evidence can be used or suppressed. So when a lawyer fails to ask a question that would reveal information detrimental to the case, and scientists, on the other hand, must be objective. They can't ignore or suppress evidence. So in a court of law, it's kind of what do you want to display? What's the point, right? In science, we don't want to do that. This is a very hard thing to do. We want to search for the truth and the absolute truth. Okay, we're not trying to hide things. We're not trying to cover up or prove one thing or another, contrary to kind of popular belief about what people think about science. Science is ultimately a search for truth. A specific scientific statement is much more than just an opinion or speculation or what somebody thinks, all right, because it has to be supported by evidence. All right, this is a break from pseudoscience. Scientists, therefore, must be totally honest. They must include all of the evidence and all of the theories. All right. Example of this: the goal maybe of an advertisement is to convince you to think a certain way. For example, to buy a product. Sometimes an advertisement might seem scientific. For example, our shampoo promises 85% shinier hair. Well, shinier than what? Like, what does that mean? And you may have noticed this a lot in like advertisements and claims that people make about, you see medication types ads and things like that. All right. In science, arguments are a means to test out ideas and give accurate explanation of an aspect of nature. So they are, for example, in the 1960s, the biologist E.O. Wilson argued that ants communicate by smells. He backed up his argument with evidence, including his careful observations and experiments he devised to test his theories. He also analyzed other theories for ant communication. A fundamental rule of science is that scientists must be totally honest. They must include all the evidence and all of the theories. You can't just single one out just because you think maybe it's not your theory. It's not what you came up with. You have to kind of include everything within that and kind of analyze those theories. All right, you can't leave stuff out. So we're starting to talk about the cycles of the moon. The phases of the moon is another way to put that. And just to kind of start out with that kind of understanding where the moon goes, it moves clockwise around, or counterclockwise around the Earth, as seen if you're like looking down at from the North Pole, like in this picture here. Moon's orbit is slightly tipped with respect to the plane of the Earth's orbit, about 5 degrees, so it's not perfectly in the same plane. It's tipped 5 degrees for the plane of the Earth's orbit. Its path is viewed from Earth. It's first slightly north, then slightly south of the ecliptic. It moves eastward 13 degrees every 24 hours. So each night you see the moon at about 13 degrees east of its location than the previous night as it moves throughout the sky. As it revolves around the Earth, its visible shape changes, and this is what we call the change, the phase of the moon. It's how much light and the angle of the light that's shining from the sun onto the moon. Right in the bottom figure here, we see first the crescent moon, and then this would be what we're calling a waxing crescent as it grows to the first quarter moon. All right, and then after that, as we grow from first quarter to the full moon, it's getting bigger, and we call this a gibbous moon with this little dome shape on it. Then we get to the full moon. As it continues to move away, we get into the waning phase of both of those. We have a waning gibbous, and then we end up in the third quarter, and then we go on to the waning crescent until we get all the way to a new moon. Interesting idea is that the moon always keeps the same side of the moon facing the Earth. They're kind of in lockstep. It doesn't change too much. The rotation of the moon and the way the moon rotates around the Earth are kind of in perfect alignment. So we always see the same side of the moon. This figure here shows that half of the moon is illuminated, is always illuminated by sunlight. If you can kind of see here, this whole half, the half that's facing the sun is always illuminated. But the way we see it, all right, is different. And generally we see it during the morning hours or the evening hours as it moves around the Earth. All right. Some people talk about the dark side of the moon, if you've heard of that before. In this figure, you can see that the entire moon goes around day and night. So there is no dark side of the moon. All right, the moon is always, there's no side that never sees the sun, but there is a side that we don't ever see. All right, so that's kind of what it is. True or false question, the moon only comes out at night. Take a moment to answer that question now. It is a false misconception that the moon only is visible at night. You probably have seen it during the day if you've really paid attention. All right, it comes up during the day. Sometimes we don't see a ton of it during the day, or not all the time. Half moons and crescent moons are harder to see, but full moon or gibbous moons are easier to see. Does a full moon make people act strange? This is a common thing that you maybe have heard, a claim. All right, this is another pseudoscientific piece. What do you think? I think that you should come to the conclusion that people's actions are not dictated by the full moon. You may think this, or this is used as a kind of, oh, well, it's a full moon, so everybody's acting crazy, or this is happening, all right? They've actually done studies on this from 3 different places that I guess crazy people exist. I don't know, or people that do weird things. Schools, for one, yay. Prisons and hospitals. So prisons, hospitals, and schools. And they show that there's no correlation between whether there's a full moon and what people are doing in those institutions. I think it's interesting they add schools in there with prisons and hospitals, but whatever. Some people act strangely, and the moon just has nothing to do with it. They're just weird. All right. Same thing with like your horoscope and the things like that. The zodiac, when you were born, has nothing to do with how crazy or not crazy or anything that you are. All right, or strange. Okay, finishing up with this, the first 2 weeks are shown at the top of the figure for the moon's monthly cycle. Note that as day 1, the new moon is at the far right of the figure. So the new moon is at the far right for day 1, if you can see down in here, day 1. And as it grows, it moves more toward the west. We talk about it growing larger. We say it's waxing, growing smaller, it's waning. So here's a waxing, this part of the cycle getting bigger. Full moon rises at sunset. So it starts over here. Remember, the new moon rises at sunrise, and the full moon rises at sunset. All right, and so that you can see that as it travels across the sky. All right. The next 2 weeks, it comes back the other way, and we get the full moon coming, setting at sunrise, the new moon setting at sunrise, or sunset, excuse me. All right, so then this is what we call the waning phase. So it's getting smaller, excuse me. These both go left to right, or right to left, excuse me, right to left, right to left. All right. And the cycle just repeats over and over and over again. Lots of calendars are set to the moon cycle. Lots of ancient calendars set to the moon cycle. Our calendar's all messed up because of a bunch of history, why we don't go by the moon cycle, and we don't really go by any cycle of anything that actually means anything. So encourage you to check that out. Maybe we'll have time to talk about that in class. The moon actually takes 27.3 days to orbit the Earth and return to the same position. This is what we call the sidereal period. Sidereal period. A complete cycle of lunar phases through all the phases. So all of the phases take 29.5 days. This is called the synoitic period. The word synoitic comes from Greek words together and path. So look at the top figure shown. You can see that the new moon and the sun are close to each other. All right. Recall that the sun travels along the ecliptic as well. The moon also travels near the ecliptic. Look at the middle figure. In this image, after one sidereal period, the moon is in its starting position with respect to the backdrop of stars, but the sun has moved. All right, so one sidereal period later, the moon is over here at its same phase, new moon, and the sun is further has moved over. All right. Now look at the bottom and its third image after one synoidic period, back to the new moon, and the sun and the moon are in the same place, and the moon is a new moon again. So the lunar cycle, we kind of think of it as being 4 weeks long, but it's actually 4 weeks and like a day and a half. All right, so it's not every month. This is why this wonderful month of October that we're in, we have 2 full moons, and the second one is what we call a blue moon, because that happens every so often with the cycle being not entirely a full month, but also a little more than a month. But some months are a little longer than others that have 31 days, like October. And so on October 1st was a full moon, and then October 31st will also be a full moon. All right, we will talk about lunar eclipses in the next video. Thanks.